today's video, we're going to learn about sets. This is basically taught in class 8 icse. Also, you can see this chapter in your classes such as plus 1, 6, 7, plus 2, right? So, set. What is a set? A set is a collection of well-defined objects. Now, what is meant by the word well-defined objects? Well-defined objects are those objects which have a definite meaning. The things that exist already. The things that do not exist are not counted in a set. Now let's talk about the elements of a set. The objects such as numbers, names that are used to form a set are called the elements of a set. Right? Let's take an example that we have a set of books. So the books are said to be the elements of the set. Now this sign that you can see, this sign, this is the belongs to sign. When we'll write about sets, we'll use this sign to represent the meaning belongs to. And this sign, when you get a slash on it, then this becomes does not belong to. Now, how do you represent a set? There are two methods to represent a set. First is the roster or tabular form, and second is the rule method or the set builder method. Now, what do we do in the roster or tabular form? Elements are separated by the use of commas. We use commas for the separation of elements, right? For example, if the set A consists of numbers 2, 5, 7, 9 and 15. So how are we going to write that? Let's see. So when you're going to write in the roster form, you'll write A is equal to, you'll put 2, 5, 7, 9. Now as I told you, we're going to separate the elements by the use of commas. So here I'm used commas to separate these elements. So what is the set? The set is the roster or tabular form. Now let's consider some examples such as the set of integers. Now you need to keep something in mind, that the integers, they start from minus, that is negative, then 0 comes in between, then positive. This thing is very important to understand integers. Secondly, if we talk about whole numbers, then whole numbers start from 0, 1, 2 and so on. Then the third part is natural numbers. You should know all these three. The natural numbers, they start from 1. This is the most important thing that you all should know, that integers start from negative, then 0, then positive. Then whole numbers start from 0 and natural numbers start from 1, 2, 3 and so on. Right? Now let's move on to the second form, the set builder form. Now do you know an interesting fact that this set builder form is also known as the rule method? Now in this form, in the set builder form, the actual elements of set are not written, right? What are not written? The actual elements of a set are not written. But a statement regarding them or a formula or a rule is written in the briefest possible way. In the briefest possible way, that is the easiest way or the smallest way by which you can write that. Now let's take an example. We take an example of let A be. Now let's take an example. Let A be the set of natural numbers less than 7. Let A be the set of natural numbers less than 7. Then you have to write them in the set builder form. Now how are you going to write them in the set builder form? As I told you earlier, you are not going to write the actual elements of a set. You are only going to write out the formula, the rule or something that can describe it in the briefest possible way. Now A is equal to X such that, these two dots stand for such that, X such that. Now what is X in it? X could be any element. x such that x belongs to, I showed you the sign for belongs to earlier also, x belongs to n. Now why have I written this capital N? Anyone? We've written this capital N because these are the natural numbers. The capital N defines the natural numbers. So x such that x belongs to n, and now you've told that it belongs to the natural numbers, and x is less than 7, right? Because we've given in the statement that it's a set of natural numbers and they are less than 7. So this way I have represented the set in a set builder form. I hope so this example is very clear to you. Now let's consider some further examples. Now as you can see, I've given a set that is in the roster form as I told you, right? Now you've been given a set that A is 2, 3, 4, 5, correct? You have to represent this set in the set builder form or in the rule method. Now how are we going to do that? A is equal to x such that x belongs to natural numbers. As I told you earlier in the starting as well, that natural numbers they start from 1 and whole numbers start from 0, right? So x such that x belongs to natural numbers, because 2, 3, 4, 5 are natural numbers, such that you can write and x is, and now you can see that these are starting from 2, that x is greater than equal to 2. Now this sign stands for greater than equal to. When you have to write greater than equal to, what sign are you going to write? You're going to write down this sign. If you're going to write greater than, then which sign are you going to write? This sign, correct? Okay, so x such that x belongs to the natural numbers and x is equal to 2, that is greater than equal to 2 and less than 6. So the elements that are in the set A are greater than equal to 2 but less than 6. Now what is greater than equal to 2? Means 2 is present in that set and the further elements are greater than 2, right? Now let's take an example for the second one. You'll be able to understand these when you do some examples, right? Now in the second one, C is 1, 3, 5, 7, 9 and 11, right? So the C set can be represented as x such that x is equal to 2n minus 1. Now if you see the order, it is 2n minus 1 such, and you can write that this n, if you would have used the word A, B, C, any word, any constant, anything, n belongs to natural numbers and n is less than equal to 6, right? Now let's move on to the third example. B is equal to 2, 4, 6, 8. Now how are we going to represent this? B is equal to x such that x is equal to 2n. Now why 2n? Where n belongs to the natural numbers and that natural numbers which are less than equal to 4. Now how less than equal to 4? Imagine if you have the natural number 1, right? So 2 into 1 will give you 2. If you have the natural number 2, right? 4 into 2 will give you 8. 2 into 2 will give you 4. 3 into 2 will give you 6. So this way we've arranged it. Similar in this way, 2n minus 1. N should be less than 6 in the natural numbers. Now if we took n to be 1 minus 1. 2 minus 1 gives you 1 and that's present in the set. If we take 2 into 2 minus 1, because it's 2n minus 1, so you have to keep the formula constant. 4 minus 1, what will that give you? 3. So you can see that 3 is also present in this set. And furthermore, you can do such examples to clarify your own self. Now, one thing that's important for all of you, you don't have to show this in exam. This is only for your understandings, your explanations, that you have to set this thing in your own minds. Don't show this in exams. Now, let's do the second example. You have to express in the set builder form again. Now, the first part, you have to express the fractions in the set builder form. Many of you would be wondering what's this it's such a difficult thing. It's not at all difficult. You can understand this very easily. You'll write it in set builder form. Maybe let's imagine that the set is A, B, C, D, anything. A is equal to x such that x is equal to n upon n plus 1, where n belongs to the natural numbers and the n is greater than equal to 7, but it is less than equal to 11. Now, how do you think that the natural numbers like that which we represented by n, they're less than equal to 11 and greater than equal to 7? See, if the natural number is less than equal to 11, now let's say that it's 10. 10 by 10 plus 1, what will it give you? 10 by 11, and that's included in the set. So this is a very easy thing, very important thing, but again I'm telling you, don't write this in the exam. This is to be kept in your own mind for your understanding. You can make a rougher column or as your teacher guides you. The second part is 0, 3, 6, 9, 12, 15 and 18. Now if we see x such that, now this is, let's imagine that it is set B, x such that x is equal to 3n, where n belongs to whole number, and for whole numbers we are going to use w, and x is less than equal to 6. The x is less than equal to 6 and n is belonging to the whole numbers, and I told you in the starting as well, the whole numbers start from 0. Please remember this thing. That's very important for you to understand this chapter sets. I hope so. This is easy for you all. If it is difficult, kindly tell me in the comment section below. I'm surely going to make a video to help you all on this. Now let's move on to the third part of this example. The third part states 1 upon 3, 1 upon 9, 1 upon 27. Don't you think it's raised to power something? If we do 3 raised to power 2, it will give you 9. If we do 3 raised to power 3, it will give you 27. If we do 3 raised to power 4, it will give you 81 and so on. And that thing is present in this particular set, right? So let's see how we are going to do it. Now let's imagine this set to be C, D, E, F, any set you want it to be. C is equal to x such that 1 upon 3n. 1 upon 3n. N could be, what is n? N belongs to natural number and n is less than equal to 5. Correct? N belongs to any natural number that is less than 5 and is also, means it is 5 is also included in the set, and the numbers, natural numbers that are less than 5, right? So this is the answer for the third part. Okay, now let's move on to the fourth part of this same example. In the fourth part, let's see what is given. Now it's given to you in the fourth part, x such that x square minus 6x minus 7 is equal to 0. Now what are you going to do in such questions is, you're going to factorize this. Now you've given x square minus 6x minus 7 equal to 0, right? So first do the factorization. X square, do you know how to do middle term splitting? Middle term splitting is easy. If you don't know how to do that, kindly tell in the comment section so that I can help you with that. Now x square minus 7x plus x minus 7 equal to 0. Now let's factorize it. X minus 7 plus 1 x minus 7. I just taken the common out here. If you don't know how to do factorization, middle term splitting, kindly tell in the comment section below. Now x is either equal to minus 1 or x is equal to 7. So how are we going to represent this set? This particular set that was shown to you, that is x such that x square minus 6x minus 7 equal to 0 is equal to 7 comma minus 1. These are the only elements in this set. So whenever you are given an equation, you're going to just solve the equation, and whatever comes as your answer for x is the elements of the set, right? Right, so now we have done with this. We've done with the roster form. We've done with the set builder form. Now I want you all to thoroughly go through what I've taught you. Thoroughly go through the examples. Now let's move on to the ending of this session for you all. There are some points to remember. The first is natural numbers. How do we write natural numbers? N. This is the capital N with which you are going to write for the natural numbers. Now these natural numbers, they start from 1 and they continue further like 1, 2, 3, 4, 5, 6 and so on. And whole numbers, these whole numbers are written in curly brackets again, then you use W sign. These whole numbers, they start from 0 and continue further. Now let's talk about integers. Integers are represented by Z. Please, that's a very important thing. You all should be clear with that. And the integers start from negative, then 0 comes in between, and then they continue till the positive, like -1 to 10, 15, whatever further, right? Now in the roster form, the elements are separated by using commas. For example, if I wrote a set is 2, 3, 4, 5 and so on. And in the set builder form, if I say A is equal to X such that X belongs to N and X is less than equal to 5, right? Means I'm not talking about this set. This is also, if I include 2 over here. But any example, anything, you all should be clear with this. These are the, you can say, nichod of this session. This is the part 1 which I had done with you. Parts 2, part 3, where they are going to come further as you all forward these videos. Please like this video if you found that something, a good content was there, and do share if you think that the others would be thinking that it's helpful for them too. And do comment if you have any doubts, or if you want any extra sessions, or if you want me to explain you any topic that is not only related to the maths. You can ask it from any subject. And if you want my help, please write in the comment section below. And if you think that this video was good, then do subscribe my channel for further home videos. Thank